Everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to launch out into Chapter 10. We're almost there. We only have 3 chapters left. Can you believe it? This is amazing. You guys are working hard. Keep it up. Chapter 10, Lesson 1. We're going to be talking today about sequences. What is a sequence? Well, I'm glad you asked because I'm going to tell you. We're on page 450. If you look down here at the screen, it says that a sequence is an ordered list of numbers that a rule determines the next number. So basically, here's the idea. A sequence is an order of numbers. It's a grouping of numbers in order. And what puts it in order? The rule. There is a rule behind it. What do I mean by a rule? Like, like a rule, like in school, like don't talk in the hallways, or no, not that kind of rule, okay? The rule is like a mathematical order to the thing. So it'll say like x plus 3, and then every time x changes, you add 1 to it. So it's got like an equation almost with it. That's the rule. The rule is a math rule, okay? Look down at the word algorithm here. Then algorithm is the rule that defines calculations for certain operations. So in other words, there is an algorithm behind a sequence. A sequence is a list of numbers, and there's an algorithm or a rule that tells it what's coming next, what's going to be the next one in the order. Let's look down here. I have a list of numbers. So I have 1, 3, 5, 7, 9. You do not have to be a rocket scientist to tell me what comes next. What is the next number in the order? Well, it's 11. Okay? Now, how did you know that? You're so smart. Okay, well, what you did was you actually, in your mind, you figured out the sequence. Probably by the time we got about right there, you figured out, okay, 1, 3, 5, I know 7 is coming next because I know my odd numbers. And so maybe you just kind of knew what was coming up. Well, if you look at this, there is actually an algorithm or a rule that is dictating what comes next. It's telling us what's going to go in that next blank. Well, here it is. A to the n, or a subscript n, equals 2n minus 1. Okay, so you really have to define what is n. So n doesn't just equal the number. N tells you which number in the sequence you're talking about. Not which number, but which, like, ordinal number. Okay, so for instance, this would be the first one. This would be the second one. Third, fourth, fifth, sixth. Okay, so n is the ordered number. Okay, all right, so what does that mean? So watch this. Let me show you how this works. If I say, okay, I want to know what comes after 11. Okay, now let's pretend we don't know. Okay, for some of you that won't be hard because you don't know. Hopefully you know. All right, so here's what it is. I know that it's going to be the 7th number. I want to know the 7th number. So if I take 2 times 7 minus 1, because it's the 7th in our order. So I would do 2 times 7 is 14 minus 1 is 13. And I could do that with whatever number. I could go out to, I could say the 357th number in the sequence, and I could figure it out using this algorithm, this rule. This is telling me what's going to come next. All right. There's 2 different kinds of sequences. There's an infinite sequence, and that means that the sequence never ends. This is an infinite sequence. Typically, an infinite sequence is either not going to have any sort of information. It's just going to say, the numbers, da-da-da-da-da. Or it's going to have this ... You know it's infinite if it has this ... because it just keeps going on forever. That ... means that. Now, the other type is a finite sequence. And how you can know that something is finite versus infinite Have you ever wondered why it's finite, why it's not finite? Well, if it's infinite, right? Why isn't it finite? I don't know. Why is infinite? Why isn't it? I don't understand these things either. Okay, so all right, you ask your English teacher that. All right, so here's my point. If it says the numbers between 7 and 21, well, you've put a limit on it. You've said, okay, it's finite. It ends. Our sequence ends at 21. Okay? So if there's no limit on it, like I said, then it's infinite. Or if you'll see, sometimes they put this ... to show that it's infinite. Okay? So two different types there. All right, this is what I kind of already talked about, but I want to kind of hit it again. In the algorithm, n is the number of the term, not the number itself. A lot of students mess this up. So they'll come here and they'll say, okay, n is, for instance, n is 11. No, n is not 11. N is 6 because it's the sixth term. So we're not talking about these numbers. We're not talking about the numbers in the row, in the order. We're talking about the actual ordinal number. Which place is it in? It's in the sixth place. Okay, so that's the sixth number. That's the number that we're talking about, the number of the term, the ordinal number. And what you do is when you put it with an a is like the variable, so it's like a to the nth number, whatever it is. So this would be like if I want to find the 21st number, I'd say a with a little subscript of 21, and that would tell me, okay, I'm looking for the 21st number of the sequence. All right, so let's look at this and let's try this. We want to figure out a to the n plus 2 times n plus 1. Basically, we want to find out this. We want to find out this sequence right here. What are these answers going to be for this sequence? So we will do this right here. We want to know what a to the 1 is, so we're going to use this. This is the first number in the sequence. So we're going to say a to the 1 equals 2, and notice what n is. N is this number right here. N is not the answer, okay? N is this number. It's the number in the sequence. So times 1 plus 1. 2 times 1 is 2, plus 1 is 3. A to the 1 there is 3. So now we're going to change up, and we're going to do a to the 2. So the second number in the sequence is 2 times 2 plus 1. Again, we're getting our number from here that goes into the n spot. 2 times 2 is 4, plus 1 is 5. The next one, we're just going to keep repeating the process. Now we're going to 3. 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. All right, if you look down on page 451, we read about the Fibonacci sequence. Here's the interesting thing about the Fibonacci sequence. The Fibonacci sequence is found, it starts with 1 and 1. So it goes 1, comma 1. And now the way that it builds is it always adds the previous two terms. So the next one is 2. Then you add these two terms. So the next one is 3. Then you add these two terms. So the next one is 5. You add these two terms. So the next one is 8. You add these two terms. So the next one is 13. You add these two terms. So the next one is 21. And so on and so on and so forth. And that is on page number 451. Now, the cool thing about the Fibonacci sequence, and this really kind of goes to God's design of the universe and the world that we live in. God designed this with patterns all around us. If you look at like sunflowers, if you look at seashells, if you look at just all kinds of different things, animals have the Fibonacci sequence. Human beings have the Fibonacci sequence. It's really neat when you study the Fibonacci sequence. What it does is it's this really cool, I wrote right here, this builds a beautiful spiraling effect. So it kind of goes around in circles, and it gets bigger and bigger as it goes around. And you can see it in different designs, like the horns of a mountain goat or a bull or something, you can see where they spiral around like a ram's horn. That's Fibonacci sequence, that curve that it has. And it's really neat. It's all over the place, and it's just one more way that we can know that there is a creator that created this world. All right, here, let's do this one. Let's see what's going on here. Let's do this algorithm. Let's go ahead and plug in. We will, the first one is 3, and so then we'll go from there. We'll go to number 2. What's the second number in this one? So a to the 2 equals 2. A to the n minus 1. Okay, so what's going on here is there's a little bit of an interesting pattern right here. What they say is this is 2 times a to the n minus 1. Well, what is a to the n minus 1? Well, first of all, what is n minus 1? N minus 1 in this case is a to the 2 minus 1 plus 5. So if we solve this, it would say 2 times a, what is 2 minus 1? 1 plus 5. Now, here's the trick. Here's where we get to this number right here. Look, it says A1. What does A1 equal? We just found what A1 equals. A1 equals 3. So we're going to plug 3 back in there now. So it's 2 times 3 plus 5. Okay, 2 times 3 is 6, plus 5 is 11. You say, I didn't really catch that. Okay, we'll do another one. We'll just keep going down this sequence, and I think you'll get it after we do a few of these. Okay, so the next one is A3. And so A3, okay, that's what we're going for because this is the number in the sequence. That's the sequence number right there. Okay, equals 2 times a to the 3 minus 1 plus 5. All we did was substituted n. What is n? In this case, it's 3 because it's the third number in the sequence. So now we just solve this, and we say 2 to the a2, or 2 times a2, plus 5. What is a2? a2 equals 11. 2 times 11 plus 5. 2 times 11 is 22, plus 5 is 27. Okay? And then we just go to it again. All right? We just erase this and go back to it. Go back to the formula one more time. So now we're doing 4. So 4 goes here, and the formula is 4 minus 1. So now we get 2 times a3 plus 5. What is a3? 27. 2 times 27 plus 5. 2 times 27 is 54. 54 plus 5 is 59. Okay, then we'll do it one more time. We just go back and we just start it over again. Okay, and now this one is a 5. And that is going to equal 5 minus 1 plus 5, or 2a to the 4. What's the 4? The 4 is 59. So 2 times 59 plus 5. 2 times 59 is 118. Plus 5 is 123. 123. Okay? And we could keep going and going and going. Okay? Now this one, there is an interesting thing. Let's say that I want to find the a to the 27. I need something. What do I need? I need a to the 26, right? I can't do that because this one is going to say you need to plug in a to the 27 minus 1, or you need to plug in a to the 26. Well, we don't know what a to the 26 is because we've skipped that all the way to the a to the 27. Now, there is a way to do it, okay? We're just not quite there yet, but there is a way to do it, and we'll get there. So that's like a little teaser of things to come. All right, arithmetic sequences is a sequence that is formed by adding to generate the next term. So instead of multiplying, it's adding every time we're adding. When you're doing arithmetic sequences, the common difference, that is the number being added. So in this case, this was kind of an arithmetic sequence because we're adding 5. Now we were also multiplying here, but we were adding 5. So that adding 5 would be the common difference because we're adding 5 each time. So the D, that's the way we say common difference, is use the letter D, is the number that's being added. All right, let's look at this one. See if you can figure this one out. 7, 4, 1, -2, -3. You're like, wait a second. I thought you said we're adding. We are. This is algebra. You should know how to add. Okay, right? So what is being added here? 7 plus what gives you 4? You're like, no, you're crazy. Nothing, 7 plus nothing. You're going backwards. I know I'm going backwards. But 7 plus -3 equals 4, right? 4 plus -3 equals 1. 1 plus -3 equals -2. -2 plus -3 equals -5. -5 plus -3 equals -8. Okay? So what is the common difference in this one? It's the number being added. What number are we adding? -3 is our common difference. The common difference can be found by subtracting a term from the following term. So if we take this right here, so if we take -2 and we subtract, so -5 minus -2, how do we do that? We add. Okay, change the sign and add. -5, so 5 minus, that's 3. Take the sign of the largest, it's negative. Okay, if you remember your rules of addition and subtraction in algebra, which you should. Come on, we're in Algebra 2. All right, so you should have been able to figure that one out. Okay, next, let's look down here real quick. I know this is a long video, but hang in there. The formula for finding the arithmetic sequence to the nth term. What does that mean when I say the nth term? Nth term means the unknown term. It means the term that we're looking for, the term that we're trying to figure out, okay? So the nth term. All right, so remember when I told you a second ago that we couldn't figure this out, this a to the 27th? We can, and I told you that we'd be able to. Now, this one's a little bit more complicated because it's not just a simple arithmetic sequence. But in an arithmetic sequence, we don't have to have the previous term. We can use this cool little formula right here to tell us whatever number that we want to find. So this is on page 453. 453. All right, let's go ahead and look down there, and let's talk about this formula real quick. This right here, this a to the first, this is the first term. So you do have to know the first term in order to solve this. So you have to have that given information. I have to tell you the first term, okay? And then, so that's the a to the 1. This n, what is this n? Okay, this is the desired term. This is the term we're looking for, okay? That's what we're trying to find. And then what's the D? We just talked about that. That is the common difference, okay? That is the difference between the things, okay? So we're just going to go ahead and use this formula now that we know what each one of them stands for. Find the fifth term of the arithmetic sequence in which the first term is 3 and the D, or the common difference, is 6. All right, so let's go ahead and plug into our formula of a to the n equals a1 plus n plus, minus 1 times the common difference. Okay, we're just going to plug into that. What do we know? We're looking for the fifth term. Okay, so a to the fifth equals a to the first. Wait, we know that. What's the first term? It says the first term is 3. So we're going to put in 3 plus n. What is n? That's what we're looking for. So the fifth term minus 1 times d. Wait, we know the common difference. It's right there, 6. Okay? All right, so now let's go ahead and let's work this. Here's what I would do. I would go ahead and, well, you can distribute. I would just solve that first, order of operation. 3 plus 5 minus, that's 4 times 6. And then 4 times 6 would be the next thing, so that is 24. So 3 plus 24 equals 27. That would be the answer. So what is the fifth term of this arithmetic sequence? It is 27. All right, let's find the fifth term of this one right here, or 15th term of this one right here. So we want to find A15, and so we're going to plug this into equals A to the 1 plus parenthesis n minus 1 times d. We need to find the common difference. What did I tell you? I said, well, you can take it and you can subtract it. So you say 17 minus 12. What's the common difference? It's 5. They keep adding 5 to each thing, okay? So the d is 5, so that goes right there. So we're going to say a to the 15 equals, what's a1? Well, it's the first term right here. It's negative 3 plus, what's n? N is our 15 because that's what we're looking for. 15 minus 1 times d, which is 5, the common difference. All right, so just solve it with order of operations. So we'll say negative 3 plus 14 times 5, 70. And so you'd have negative 3 plus 70, or you'd have 67 would be our 15th term of that arithmetic sequence. Okay? Again, that was a lot of information. That's a heavy chapter right there, heavy lesson, but hopefully you learned some things there. Go ahead and try some of those practice problems. Go back, learn that formula. That formula is super, super important. Okay? All right, well, that's all I have for you. You guys have a good rest of your day. Bye-bye now.